Hello friends, welcome back to Civil Depth BD. Today we will go for step number 5 for this G plus 4 storied residential building. That means we will define load pattern for earthquake load. Let's go to define, then go to load pattern. Here I will write EQX. Type will be seismic, self-weight multiplier will be 0, auto lateral load, here we will take ACI 705. Click on add new load, then write here EQY, type will remain same, that means seismic, self-weight multiplier will be 0, auto lateral load, that means we will follow ASCE 705 code. Click on add new load. Just click on OK. Again, go back to define load pattern, then come back to EQX. Now go to modify lateral load. Here for X direction, we will not consider any seismic loading in Y. Also, we don't need to consider X direction. Here we will consider X direction plus eccentricity and X direction minus eccentricity. That means for the design in ultimate state, we will consider minimum 5% eccentricity. Okay, now we have to provide the value of time period. We have to provide several factors like response modification, strength, over strength factor, then deflection amplification factor, occupancy importance factor, and so on. So we have to calculate them from our code book. Click on OK. Again go to EQY, then go to modify lateral load. For Y direction, we don't need any seismic loading in X direction. Also we can uncheck Y direction. Now click on OK. Here we will follow BNBC 2020, which is totally similar to ASCE 705. So this is the book. Now we have also prepared a Word file here. At first we will do some manual calculation here. After that we will input these values in ETABS. At first we need to know the length of floor and width of floor. So go to AutoCAD. Here we can see the length of floor is 46 feet 10 inches. That means we can say 46 feet 10 inches. Width will be, here we can check, we will take the outmost edge. Here this one is 51 feet 7 inches. 51 feet 7 inches. Now we need to know the height of building, but we have to deduct the height of overhead water tank or lift core. Okay. Now go to ETABS, then go to edit stories and grid system, modify / show story data. Here this one is the roof. Here this is the roof floor. After that this one is water tank bottom slab, water tank bottom slab, water tank top slab. So we have to take height up to roof, that means 58 feet. Click on OK, refresh view, OK. Here the height is total 58 feet. Just write here 58 feet. Now convert this to meter, 58 feet. In ACI code, basically they take the height in meter. Sorry, they take the height in feet, but in our BNBC 2020, they are telling us to take the height in SI unit. That means in meter. So what will be the value? 58 divided by 3.28. This is 17.68 meter. 17.68 meter. Now we have to input subsoil investigation data in this chart here. Suppose this is a demo of soil test report. Suppose for each 5 feet interval you have the N value from the soil test report. Here in 5 feet the N value is 1, for 10 feet N value is 2, for 15 feet 5. Suppose we have prepared, here we have prepared a soil test data. At 5 feet N value is 3, at 10 feet N value is 7, for 15 feet 9, for 25 13. Okay, now at first we have to decide what is the type of our soil. Is it in soil type category SA or SB or SC or SD? So what will we do? At first we will go to the graph, then we will take decision about the height of the foundation, okay, or depth of the foundation. Suppose here these values are kind of similar, so we can take this layer for the as the hard layer for our pile foundation. That means here this is 80 feet, here this is 80 feet, or you can go for any kind of other foundation. You have to consider if you are going for the design of shallow foundation, in that case you have to take a layer from here maybe, okay. Or if you are going to design the foundation of this structure as a sand pile or anything, in that case you have to take any layer from the above. Here I am considering this layer, that means 80 feet layer for casting C2 pile. That means we will note down these values, these N values, and put them into the Word file. So here we have inputted all the values from the soil test report up to 80 feet height, After 80 feet we don't need the N values anymore, so we deleted them. Now here Ni, already you can understand, here Ni is the uncorrected SPT value, or you can say field SPT value, and Di is the thickness of layer I. In step 4 we have to calculate N bar. For calculating N bar we have to go to BNBC 2020 and page number will be 611. This page number is for PDF book actually. So let's go to here. Okay, I am already in 611. If you are in any page here, just go to this box and write here 611. The actual page number as per the BNBC is 3189, but 611 is the PDF page number. Here you can see the formula for N bar. We have written this formula in our Word file, that is N bar equals summation of Di divided by summation of Di by Ni. And we have written all the layer thickness here up to 80 feet, and for summation of Di divided by Ni we have written all the values here. The summation of the values above is 680 and the summation of the numbers below is 52.05. Finally we are getting the result is 13.03. That means we can say the value of N bar is 13. Now as per this value we have to take decision about the site class. So go to page number 612 in BNBC 2020. Here you can see site classification based on soil properties. Site class A, if shear wave velocity is greater than 800, we will not go with this method. We will go for SPT value N bar. For SPT value or N bar, site class will be minimum SB. In our country, soil type or site class SB is not available as much information as I have. So for site class SB, minimum SPT value or minimum average SPT value should be greater than 50. But in our case, the value of average SPT is only 13. So we can go downward. For site class SC, SPT value or N bar value should be between 15 to 50. So we can say this is not the site class of our soil. Now we can go downward and here we can see SD. That means for N bar values less than 15, we can consider this soil as SD type soil, which is deposits of loose to medium cohesionless soil with or without some soft cohesive layers, or of predominantly soft to firm cohesive soil. That means the site class of our soil is SD, because here in our case the value of N bar was 13, which is less than 15. That means we will consider the site class of our soil as SD, because this is less than 15. Less than 15. Now we have to determine the seismic zone coefficient. That means for which region we are going to design this structure. So go to page number 617. This is again the page number of PDF. Here we are designing this structure for Dhaka, which is the capital of Bangladesh. This Dhaka is at zone 2. How we can understand this? Here you can see this green color is for zone 1, this yellow color for 2, blue color is 3, and red color is for zone 4. Here we can see Dhaka is located in yellow zone. That means we can say this Dhaka is at zone 2, is in zone 2. Okay. Here also we have a description of seismic zones. Here this is telling us that seismic zone 1 means seismic intensity will be low and seismic zone coefficient will be 0.2. For 2, seismic intensity will be moderate. For seismic zone 3, seismic intensity will be severe. For 4, seismic intensity will be very severe. Here they have also provided a zone coefficient chart. Basically this is these values are written here by a regular format. Here from here we can see for Dhaka zone coefficient is 0.20. Also we can find this from here also. Now write this value in here. I will write Dhaka because we are designing this structure for our capital Dhaka city. Seismic zone coefficient will be 2 and zone coefficient will be 0.20. Now we have to determine structural importance factor I. So let's go to page number 619. Okay, before going before finding the importance factor, we have to go to page number 483 actually. We have to go page number 483. So from here we have to take decision about the nature of occupancy. After determining the nature of occupancy, we can find out the occupancy category. Here they have written for agricultural facility, certain temporary facility, minor storage facility, we can consider occupancy category 1. For occupancy category 2, they didn't mention any specific category here, but they have mentioned for occupancy category 3 and 4. If our structure is not in occupancy category 1, 3 or 4, in that case we can say that our structure is in occupancy category 2. For your information, if you are designing a pure residential building, without any hesitation you can consider this structure in occupancy category 2. You can read them. You can read them. You will easily understand that our structure will be in occupancy category 2. Let me give you a brief. Buildings and other structures where more than 300 people congregate in one area. In our structure, there is no chance. Building another structure with daycare facility with having a capacity greater than 150, no chance. Building another structure with elementary school, no chance. Capacity greater than 250 for school. For adult education facility, capacity should be greater than 500 if you need to consider this structure in occupancy category 3. But in our case, there is no chance. In our case, there is no healthcare facility. Also, there is no surgery or emergency treatment, so we cannot consider them in occupancy category 3. Similarly, for hospital and healthcare where they have surgery, where they have in occupancy category 3, they told not having surgery, not having surgery. Let me erase them, not having surgery. Okay, but for occupancy category 4, you can see they are talking about having surgery or emergency treatment facility. But in our case, there is no possibility. This is a pure residential building. This is not a emergency structure. That means not for any fire rescue, ambulance, police station, not for hurricane shelter, not for emergency communication or anything, or power generating room, ancillary structure, nothing. That means we can say the occupancy category of our structure is 2. So we will write here occupancy category or occupancy type 2. Now, as per this occupancy type, we have to take decision about the importance factor. So go to page number 619. Go to page number 619 here. Then find out the importance factor I. Here you can see for occupancy category 1 and 2, importance factor should be 1. So right here I equals 1. Now go to step number 7. That means we will calculate time period T. T equals Ct Hn to the power m. But we don't know the value of Ct and m. So we have to take decisions about Ct and m. Let's go to page number 631. 631. Values for coefficients to estimate approximate period. Here we are not designing any steel structure. We are not designing any eccentrically bracket steel frame. We have to take decision between concrete moment resisting frame and all other structure. This is a pure residential building. There is no shear wall, or we can say there is no sufficient shear wall to resist the vertical forces or shear forces, axial forces actually. So we can consider this structure as concrete moment resisting frame. If there was sufficient sufficient shear wall which could take forces between concrete frames, that means before column, in that case we could consider our structure as dual system. We will discuss this dual system in some other separate tutorial, because in this case there is no possibilities of considering this structure as dual frame resisting system or in all other structural system categories. So we have to take concrete moment resisting frame 0.004, 0.0466 and 0.9. So write this value 0.0466 and 0.9. So the formula is T equals Ct Hn to the power m. Input the values of Hn here, maybe 17.68 meter, maybe 17.68, right, 17.68 meter. Note that in ACI code they have taken to they have told to take this value of Hn in US customary, or you can say in FPS unit, but in BNBC 2020 they are telling us to take this value in SI unit. So we are doing so. Now we have to calculate 0.0466 into 17.68 to the power 0.9. So we are getting 0.618. We will write this here 0.618. Let me calculate again. 0.0466 multiplied by 17.68 to the power 0.9. Okay, fine. 618 second. In step 8, we have to take decision about the seismic design category of our structure. Let's go to page number 620. 620. Here they have given a chart for determining the seismic design category of a structure. You can see for site class as A, as B, as C, and as D. The site class of our soil is as D. So we have to find out the values in this row. Also, we have zone 2. We are designing this structure for zone 2. That means for occupancy category 2, for site class as D, for zone 2, the seismic design category of our structural will be as D. If you draw a line in this direction, and draw a line in this direction, you will see these two lines will intersect at D. That means the category of our structure, or we can say the seismic design category of our building, will be SD. Now you have to understand what is SB, SC, or SD. If you go here, you will see buildings shall be assigned a seismic design category among B, C, or D based on the seismic zone, local site conditions, and importance class of buildings as given in table 6.2.18. We have already seen this table. Now seismic design category D has the most stringent seismic design detailing. That means you have to confirm strongest or stringent seismic design detailing for seismic design category D, while seismic design category B has the least seismic design detailing requirements. That means for seismic design category B, you can go with minimum seismic design detailing requirement. For seismic design category C, you have to go with moderate seismic design detailing requirement. But for seismic design category D, you have to go with the strongest or stringent seismic design detailing requirement. So in our case, this is seismic design category D. For site class as D and for zone 2. Note that this seismic design category is connected with site class and seismic zone. Now we will go for step number 9. So that means we have to go at page 624. Here we have different types of structural system. At first we can see bearing wall system. We can see building frame system with bracing or shear wall, but in our case there is no shear wall in our structure which will resist vertical forces. So we cannot go with type A or type B. We will go for type C. That means moment resisting frame, no shear wall. That means all the moments will be carried out by the frames. No, there is no shear wall. That means we will take data from this table C. Here you can see we are not designing any steel structure here. We will go for special reinforced concrete moment frames, and we will take R value as 8, omega naught 3, and CD value will be 5.5. Here we also have another category which is dual system, but for our case this is not dual system. For our case this is a moment resisting frame with no shear wall or no shear wall. So we will take R value 8, then strength over strength factor 3, CD may be similar 5.5, right? Now we will go for step number 10, that means seismic design parameter. We have to find out from BNBC 2020. So we have to go in page number 1618, right here 1618. Here you can see the value of SS and S1 are indicated below. For zone 2, this value will be 0.5. This means that means the value of SS and the value of S1 will be 0.2. S value will be 0.5, and this S1 value will be 0.2. Here we are taking these two values. Also, we have to find out the values for FA and FB. So for soil type SD, for zone 2, we can see our required value is 1.35. 1.35, that's okay. FB will be 2.7. 2.7. Now come back to step number 11, long period transition period. If you are directly designing this structure for USA, you will see that in ACI code they have separate values of long period transition period for a separate zone. But in our country, that means in Bangladesh, for all structures we have to consider long period transition period equals 2 seconds. Again, I am mentioning, if you are designing this structure for USA, in that case you have to check the long period transition period value with ACI code. Okay, here you can see the map for long period transition period in AC 705 in figure 20-12. For separate zone, they have separate values of long period transition period. Let me show you this book. This is, sorry, this one is ASC 7110, not 705. This is 7110. You will get the same values in 705 also. That means if you are going to design your structure for USA, in that case you have to consider separate values of long period transition period as per your zone. But for Bangladesh, we have to take here long period transition period equals 2 seconds only. Okay. In ETABS, we have to define site class as F, otherwise we can't modify these values of FA and FB. We will discuss this very soon. Now we will go for the calculation of base shear. Formula is V equals SA into W. Here we have written SA equals 2/3 into ZI divided by R. In our case, seismic zone coefficient is 0.20, structural importance factor 1, response reduction factor 8. Then we have already the time period value, which is 0.618 second. Now we have to go to page number 619 in BNBC 2020, 619 here. We can see for soil type SD, S value is 1.35, S value is 1.35, value of TB is 0.20, 0.20 here, value of TC is 0.80, TC is 0.80, and value of TD equals 2 seconds. That means we can say this long period transition period, which is 0.618 in our case, is greater than TB, that means greater than 0.20 second, but less than TC, that is less than 0.80. Okay, so we have to find out the formula for calculating CS as per this condition. Hope you can understand. So let's go to page number 615 in BNBC. 615 here. You can see the formula for calculating CS when the case is T greater than TB but less than TC, the formula is CS equals 2.5 as eta. That means we will not take this factor TC by T. Okay, let's delete this one. Take a snapshot from here. Take a snapshot from here. We can save this in desktop. Now we can insert in our Word file. So this is the formula here. As value we already know 1.35, but eta. But for eta we have a recommended value. For 5% damping ratio, the value of eta should be 1. So now we can calculate the value of CS. We can copy this one and paste here. So the formula will be without this factor actually. 2.5 S into eta. That means 2.5 into 1.35 into 1. 3.375. 3.375. Again, we have to calculate the value of SA. The formula was S equals 2 by 3 ZI divided by R into CS. Now we know the value of CS, so we can calculate SA. 2 by 3, Z value is 0.20 here, Z value is 0.20 here, I value 1, the value for R is 8, and the value for CS is 3.375. So we can calculate this as a 2 into 0.2 into 3.375, 2 into 0.2 into 3.375 divided by 24, divided by 24. That means 0.056. 0.056. Again, we have to calculate as a minimum as per BNBC 2020. This is similar in ACI code also, which is 0.67 beta ZIS. We have to take value between SA and SA minimum. We will take the higher value, whichever is higher. So if we calculate SA minimum by using this equation, that means 0.67 beta ZIS, we are getting beta value 0.11 from the recommended value in our code. Coefficient used to calculate lower bound as a recommended value for beta is 0.11. We have written this. The value for Z will be 0.20, I value 1, S value 1.35. So we can calculate as a minimum 0.67 multiplied by 0.11 multiplied by 0.20 multiply with 1.35. We are getting 0.0198. 0.0198. That means higher value is 0.056. So SA greater than SA minimum, hence we will go with SA. Otherwise we could take SA minimum. So here we will calculate V equals SA into W. That means V divided by W equals SA. That means here we can write SA value equals 0.056. Now we will multiply this 0.056 with 100% and we will get 5.6%. 5.6%. That means the base share ratio will be 5.6%, which we will check in ETABS after analysis. Okay. Now go to ETABS. Now we can go to ETABS. Then go to define load pattern, EQX modify. Here time period will be 0.618 as we have calculated. The story range will be from bottom to the top. That means from base to water tank top slab. In our case, response modification factor R equals 8, omega equals 3, CD equal to 5.5. Already we have calculated, so there is no necessity of changing these values. Occupancy factor 1, also SS value. We have to change these values here. The value for SS is 0.5 and 0.2. For S1, 0.5 and 0.2. Long period transition period 2 seconds. Site class we will take FA. If we take A, we can modify this value of FA and FB. If we take B, we can't change again, but if we take F here, we can change these values here. So we will input FA value, which is 1.35, and the value for FB, which is 2.7. 1.35, we will input 1.35. When I will press enter, you will see that this value will be changed as per this equation. Enter. So this value now is 0.45, and for FB we will input 2.7 as per our manual calculation. 2.7. Enter, and finally you can see that this value has been changed also. So what we have done, we have inputted the value of time period, story range, factors, SS, S1, long period transition period, site class, FA, FB. Now click on OK. Now go to EQY, go to modify lateral load. Here input time period 0.618. The story range will be between base to water tank top slab. No need to change here any values. Here SS value will be 0.5, S1 value will be 0.2, SS and S1 0.5, 0.2, long period transition period 2 seconds, long period transition period 2 seconds, site class F 1.35, and here 2.7. Okay, so we have completed the procedure of defining load pattern for earthquake in ETABS. Here this is a long period transition period 2 seconds. Fine. For this one, let me check for EQX. Okay, 2 seconds here. So today we have completed up to step number 5. In next tutorial we will see how to define load pattern for wind load in ETABS with all the calculations. That's all for today. See you in the next tutorial. Thank you.